Determine the force in members EF, EP, and LK of the Baltimore Bridge truss and state if the members are in tension or compression. Also indicate all zero force members. In order to solve this, let's first of all determine our zero force members. So it's simply going to be our perpendicular members, NB, and then NC. Also going to have OD and OC, and then GH and JG, and member LE. These are all our zero force members. And now let's solve the problem. First of all, for every truss problem, we have to find our external reaction forces. And by inspection, we can say that AX is going to be 0 because there isn't any other horizontal force acting on this truss. And we have vertical horizontal forces at A and I. And because we're going to use method of section to determine certain members' forces, we just have to determine which side we're going to use. And I'm inclined to use right-hand side of this truss, where I'll be cutting through, where I've drawn this blue line. Okay, so this means I just need external reaction force for I, and I can find that by taking the moment about the point A. We're going to have clockwise 2 kilonewton forces. First one is 4 meters away from E, and the second one is 12 meters away from A. And then we have 2 more external forces of 5K and 3K. 5K is 8 meters away, and 3 is 10 meters away. And finally, we have counterclockwise IY, and it's 16 meters away from E, all equals to 0. Solving for IY, we get our solution as 6.35 positive. This means we assume the vector direction in the right direction. And now that we have our reaction for I, we can start solving for our external reaction forces. But before we do that, we need to draw our free body diagram in order to visualize what our section, our right section, is going to look like. So we're going to have I with the diagonal member till K, and at K we're going to have a reaction force KL. Then we're going to have our members till F, and at F we have external reaction force of 3 kilonewton, and we have another one at G of 2 kilonewton. And then we have member extending vertically till point P, and at P we're going to have our diagonal reaction force of force PE, and we have horizontal reaction force of force EF. Okay, now to solve, we're going to have our imaginary point E, and we're going to take a moment about the point E. In doing so, we're going to have clockwise 3 kilonewton, 2 meters away from E, and clockwise 2 kilonewton at G and 4 meters away from E. And then we're going to have force KL clockwise, and it's 4 meters away from E. And finally, we have counterclockwise external reaction force IY, and it's 8 meters away, all equals to 0. So for force KL, we get our solution as 9.25 kilonewton, and this member is in compression. Now we can sum the forces in y direction in order to find a solution for force in member PE. we're going to have vertical component of force PE, which will be cos 45 degrees times force PE. And then we're going to have downwards force member, external force member at F and G. Adding them together, it's negative 5 kilonewtons. And finally, going upward are IY, which is 6.375 kilonewton, all equals to 0. All for force PE, we get our solution as 1.944 kilonewton. Positive, so that means we assumed our vector direction to be right. And this vector tells us that this member is in tension. Now we can sum the forces in x direction. When we sum the forces in x direction, we're going to have force EF, which is in negative direction, positive KL, and horizontal component of force EP or PE, which is negative, all equals to 0. Solving for EF, we get our solution as 7.875 kilonewton. And because our solution is in positive, this means we assumed our vector direction to be in the correct